Here is a shaded square. Write the coordinates for point A. So we have point A here, and we know that when we write coordinates, we have the x coordinate first, so we need to go down. We can see that point A is in line with point D, and that has an x coordinate of 3, so the x coordinate for point A will be 3 as well. Now let's look at the y coordinate. We can see that point A is in line with point B, and the y coordinate, so the second number for B, is 11. So that means point A must have a y coordinate of 11 as well. So the coordinates for point A are 3, 11. This table shows the number of things to eat in 5 children's lunchboxes. Here is a graph of the information for 4 of the children. Which child's information is missing from the graph? So if we look at our bar graph, for sandwiches we have 6, but if we count the total number of sandwiches, we have 1 plus 2 plus 1 plus 1 plus 2, so that's 7. So that means one of the children with only one sandwich will be missing from the bar chart, because 7 is one more than 6. So that means it's either Lisa, Kemi or Nick. So we can cross off Jack and Ben. Now let's look at apples. We have 4 apples on our bar chart, but 2 plus 0 plus 1 plus 2 plus 1 is 6. So there are 2 fewer apples on the bar chart than there should be. So that means either Lisa or Nick have their information missing from the bar chart, so we can cross off Kenny. Now let's look at bananas. We have 4 bananas on our bar chart, but 0 plus 2 plus 0 plus 1 plus 2 is 5, and 5 is one more than 4, so that means it must be Nick, because Lisa has 0 bananas. So we know that Nick's information is missing from the graph. And to check, let's look at fruit bars. On the bar chart we have 6, and altogether we have 6 fruit bars in the children's lunchboxes. And that makes sense because Nick has 0 fruit bars, so if his information is missing, it won't make a difference to the size of the bar. A rectangle has an area of 100 centimeters squared. How long could the sides of the rectangle be? Give 3 different examples using whole numbers. So remember, the area of a shape is the amount of space it takes up, and we find the area of a rectangle by multiplying the width and length. So if we had a rectangle with a width of 1 centimetre and a length of 100 centimetres, the area would be 100 centimetres squared, because 1 times 100 is 100. We could also have 2 centimetres as our width and 50 centimetres as our length, because 2 times 50 is 100. Or we could have 4 centimetres and 25 centimetres, because 4 times 25 is 100. Or 5 centimetres and 20 centimetres, because 5 times 20 is 100. Now if we had 10 centimetres and 10 centimetres, if both the length and the width were 10 centimetres, then we wouldn't have a rectangle, we would have a square. So we need to give 3 different examples, so we need to use 3 of these. Complete the missing numbers to make the calculations correct. So we have 3/10 plus 3/1000, and our answer has a denominator of 1000. Now when we're adding fractions, we need the denominators to be the same. So we need to find an equivalent fraction to 3/10, which has a denominator of 1000. 10 times 100 is 1000, and 3 times 100 is 300. So now 300 thousandths plus 3 thousandths makes 303 thousandths. Now we have 7 tenths plus 7 thousandths, but this time we need to give our answer as a decimal. We can get our denominators the same, add our fractions, and then change the answer that's a fraction into a decimal. So 7 tenths is the same as 700 thousandths. Again, when we're adding fractions, we need the denominators to be the same. And 700 plus 7 is 707, and our denominator stays the same. Now, if we have 707 thousandths, we have 0.707. The third digit after the decimal point is the thousandths digit, so this denominator of 1,000 tells us that we won't go beyond the thousandths digit. Remember, we can only have one digit in each place value, so that means this 0 gets pushed over into the hundredths, and this 7 gets pushed over into the tenths. The other way to solve this question would be to change our fractions to decimals. So 7 tenths is 0.7 because the first digit after the decimal point tells us how many tenths we have, and then 7 thousandths is 0.007 because the third digit after the decimal point tells us how many thousandths we have. So then 0.7 plus 0.007 equals 0.707, because remember, when we add decimals, we can put zeros on the end so that the numbers have the same number of decimal places. Here is a quadrilateral drawn on a square grid. On the same grid, draw a different quadrilateral that has the same area. So a quadrilateral is a shape with 4 sides, and the area is the amount of space a shape takes up. So we need to think, how many squares does this quadrilateral take up? Well, if we look at this part here, we can see that that's half of 2 squares, so that's the same as 1 square. This part here is the same as 1 square as well, because again, it's half of 2 squares. So we have 1, 2, 3, 4, 5, 6 squares in our shape. So we need to draw a 4-sided shape with an area of 6 squares. So we can draw a 2 by 3 or a 6 by 1 rectangle, because that way we have a quadrilateral, we have a shape with 4 sides, and it has the same area because it has the same number of squares inside it. The area of both the trapezium here and the rectangle that we've drawn is 6 squares. There are 12 points marked around this circle. The points are equally spaced. Join 3 points to make an equilateral triangle. So the word equilateral is important because the sides of an equilateral triangle are all the same length. So to find where our points need to be, because we have 12 points altogether and we need to join 3 of them, we can divide 12 by 3, and that tells us that there will be 4 points from one vertex or corner to the next. So if we take a point, we can count 1, 2, 3, 4, 1, 2, 3, 4, and then notice we have 1, 2, 3, 4 points to get back to where we started. So then we can join up our points and we have an equilateral triangle because all of our lines are the same length and all of the angles are the same size. So remember, angles in an equilateral triangle are always 60 degrees. Now there are lots of possible answers for this question, but as long as you've left 3 points between each of the points that you've joined, then you have the correct answer. An iced cake costs 10 pence more than a plain cake. Sarah bought 2 of each cake. They cost £1 altogether. What is the cost of an iced cake? So one way to solve this problem is to use a bar model. Sarah bought 2 iced cakes, so we can show 2 bars for iced, and she bought 2 plain cakes, so 2 bars for plain. They cost £1 altogether, so altogether Sarah spent 100 pence, or £1. Now we know that an iced cake costs 10 pence more, so underneath our iced bars we can draw another bar and 10 pence. So now, looking at our second row, we have 2 bars that are 10 pence, so that's 20 pence, and if we subtract that from 100 pence, we get 80 pence. So these 4 bars together are worth 80 pence. To find the value of 1 bar, we can divide by 4 because we have 4 bars that we need to find, and 80 pence divided by 4 is 20 pence. So the value of these bars is 20 pence. So that means a plain cake must cost 20 pence, and then an iced cake costs 20 pence and then another 10 pence, so that's 30 pence altogether. Mina thinks of a 3D shape. She says it has 5 faces. 2 opposite faces are triangles. The other faces are rectangles. What is the name of the 3D shape? So if we show the shape that Mina is thinking of, we can see that 2 opposite faces are triangles because we have a triangle here and then another triangle at the back. And the other faces are rectangles because we have a rectangle at the top, a rectangle here, and then a rectangle down below. So that's 5 faces altogether because we have 2 triangular faces and then 3 rectangular faces. So the name of this shape is a triangular prism. And the word prism tells us that we have the same 2D shape at both ends, and then we have rectangles joining the 2 opposite faces. Draw the reflection of the shaded shape in the mirror line. So to reflect a shape, we need to count squares. So if we look at this square here, from the mirror line, we go across 1 square and then shade. So to reflect it in the other direction, we can go across 1 square and then shade. For this square here, from the mirror line, we go across half a square, across another square, and then shade. So in the other direction, we can go across half a square, across another square, and then shade. For this square here, we go across a square and then shade. So from the mirror line, we go across a square and then shade. And finally, this square here, we go across half a square, across another square, and then shade. So we go across half a square, across another square, and then shade. So we've reflected the shape in the mirror line because we have the same on both sides, and each shaded square is the same distance from the mirror line on both sides. Some children take part in the long jump. The graph shows the distances the children jumped. Estimate how much further Lucy jumped than Nicola. So we can find the bar for Lucy, and if we go to the end and draw a line down, we can see that Lucy jumped 180 centimetres. We want to compare that to how far Nicola jumped. So we can find the bar for Nicola, and when we go to the end and draw a line down, we can see that that's between 100 and 120, but it's closer to 120. So I would estimate that Nicola jumped 115 centimetres, because that's closer to 120 than it is to 100. But notice my estimate is not 119, because with 119, that would almost be touching this line that shows 120. So 115 is the best estimate here. Now we want to know how much further, So we need to compare these values, so to find the difference. And to do that, we use subtraction. 180 minus 115 equals 65. So Lucy jumped 65 centimetres further than Nicola.